It's a simulation model of the Arctic Ocean with ice and ocean coupled together. We're funded by BOEM, the Bureau of Ocean and Energy Management. They're interested in what the surface currents are and the surface winds and surface ice motion, and they take those three fields together and they produce maps of where oil would go in the event of an oil spill.
Lots of ice coming.
In the summer, the blue there is the open water, and the gray, the light gray, is at least 90% ice cover. And so every summer you get some of the ice retreating, melting away, and then in the fall it grows back. And the exact position of where the ice edge is isn't quite right, but we have roughly the right amount of ice, and that's dominated by the thermal forcing, which comes from that atmospheric model that we're using. And so we're confident that we're getting about the right amount of heat coming into the system and leaving the system.
The ice is really difficult to get, especially in the Arctic, the multi-year ice. In the Bering Sea, the ice is reset to zero every single year, so you can start growing ice in the fall in a fairly realistic fashion. But if you have ice in the Arctic, which doesn't go away every year, if you have an offset one year, that could grow and influence your results for the following year and the year after that. So it's a more difficult beast to get the ice right in the Arctic.
Another thing we've done in this particular simulation is we've added a land-fast ice component, and we're using data from Andy Mahoney. Andy Mahoney did his thesis studying the land-fast ice of the Alaska Beaufort Sea. It's a place where every winter land-fast ice is generated and then breaks up and floats away come summer. And so the timing of that is of interest to the native communities, because there have been people who've been out on the land-fast ice and then a huge chunk of it just breaks away and they're floating away and they have to be rescued. And the behavior of that, I think, has changed over the decades.
I don't know the internal dynamics of ice probably as well as she does, but the character of the ice can change with thickness and with temperature. You have to get a lot of other things right to get the ice close to right.
Next phase, if we were to do more work on this project, would be to learn how to create an ice model that could be run in a limited domain. We've been doing that for years with the ocean, and using boundary conditions from larger ocean models, we can make a pretty good small regional ocean model that doesn't have a lot of boundary effects. But in the ice model, I described earlier that I was having all kinds of trouble with the ice edge being either too stiff or not stiff enough. And we'll have to tackle that problem to do a nested model, much finer resolution along the coast, because we're not resolving the barrier islands along the Beaufort Shelf there. And that's where the oil drilling is taking place. BOEM would like to see a model that gets really down to where we can resolve those barrier islands. And we wouldn't be able to afford to run the whole Arctic at that resolution, so we need to do a nested model and figure out how to provide enough conditions from the exterior ice field to the smaller ice patch to make it well behaved.
What happens is she can get numerical instabilities occurring when portions of the model computations are not behaving well. For instance, if you make a water that's too shallow and your currents are going too fast because you've got strong tidal currents, then you can get a numerical instability and try to create predictions of velocities and sea surface height that are so unrealistic, the model dies because it can't handle it. It knows something is so completely out of whack.
The whole system up there is changing a lot. They've had talks lately about how just the nature of the pack ice itself has changed from being really solid and thick to being all multi-year ice to being just little patches of multi-year ice with the first-year ice in between. And so it's not as stiff as it used to be. Just interesting changes going on. But we will have ice every winter as long as it remains dark up there in the winter, I believe.